Good morning, friends. So, this is my next lecture on GOC, that is General Organic Chemistry, and today we are going to discuss the last electronic effect, that is the electromeric effect. Electromeric effect. So, this is the last effect, the last electronic effect, that is the electromeric effect. As far as electromeric effect is concerned, this electromeric effect is a temporary effect. It is temporary effect. This temporary effect. Now, if you consider most of the organic molecules, they are polar in nature, and the attacking reagent, if you consider that attacking reagent may or may not be polar, but most of the organic molecules are polar. Attacking reagent also polar or not polar, no problem. Now, in that case, due to polarity of reagent or polarity of the substrate, the reaction takes place. Chemical reaction between them takes place, isn't it? But now there are most of the reactions in which substrate is non-polar, or has very less polarity, and also the attacking reagent also has non-polar nature, or it may have less polarity. So as substrate and reagents both are having less polarity or non-polarity, even though the reaction between them easily occurs. We understood if there is a polarity either in reagent or substrate, reaction proceeds, isn't it? But in case of non-polar, also the reaction occurs, isn't it? So how this can be explained by means of a new concept, electronic effect, that is the electromeric effect. Now, best example how that can be explained, if you consider an example, that is the halogenation of alkene. That is also called as that is the decolorization of bromine water. Decolorization of bromine water. It is a characteristic. If you consider example, suppose if you consider the CH2 double bond CH2, that is ethylene plus bromine water, it results in the formation of, that is, bromine CH2 bromine. So this is the brown colored. Means when you add the bromine water in unsaturated substance, that is containing multiple bonds, either double or triple, then brown color of bromine disappears, and this is the characteristic test to check the unsaturation present in the organic molecule. So simply this is the addition type of reaction. In which bromine molecule adds across the unsaturated carbon, one bromine here and one bromine here, isn't it? Now in this case, this ethene as well as bromine both are non-polar in nature. Still the reaction occurs. So this reaction can be explained not by means of hyperconjugation, not by means of inductive effect, not by means of resonance. It can be better explained by means of a new concept, that is the electromeric concept. Now it is explained by means of electromeric effect. Now see here. So if you consider any alkene, isn't it? If you consider that is the this best example, CH2 double bond CH2, ethylene, same example, and then bromine water to forms, that is the CH2 single CH2 bromine, isn't it? No additional product is formed because it is simply addition reaction. As far as mechanism of this reaction is concerned, now what happens when bromine When bromine, if I write bromine here like this, Br dash Br with their lone pairs of electrons on each bromine atom, isn't it? There are 6 electrons, that is 3 pairs of electrons on each bromine. When this bromine approaches the alkene, that is ethylene, then what happens? The pi bond of ethylene and the lone pair on each bromine, there is a interelectronic repulsion. And due to that interelectronic repulsion, the pi bond is shifted on one carbon atom, resulting in the production of the polarity in molecules itself. And due to which, when bromine attacks over the pi bond, what happens? Yes, one of the pi bond between carbon and carbon, suppose it is shifted on this carbon atom. As this pi bond is shifting on this carbon atom, it creates negative charge on this and results ultimately positive charge on the another carbon atom. At the same time, this bromine, when Br minus in the sense positive charge, so this Br attacks on the positively charged carbon atom. It attacks on positively charged carbon atoms. When bromine carbon bond formation going to occurs or going to takes place, at the same time, this another bromine atom from bromine molecule leaves as a bromide ion, with electron pair, and the negative charge on carbon forms a bond with this bromine atom. So ultimately the product formed is CH2 single bond CH2. This is bromine carries positive charge. This is called cyclic bromonium ion. Now see, with it is the one bromide, that is the Br minus. Now see, this carbon forms bromine bond. At the same time, what happens? This negative charge comes between carbon and this bromine, so it forms cyclic bromonium ion. This cyclic bromonium ion is unstable because the electronegative atom carries positive charge. And that's why it's unstable. And in next instant, what happens? Yes, this Br minus attacks over this carbon atom. Either it attacks this or this, no problem, because both sides are, it is the symmetrical in nature. It may attacks on this carbon atom, it may attacks on this carbon atom. When it attacks on this carbon atom, this lone pair, yes, when it attacks on this carbon atom, then what happens? The lone pair between, that is bond between carbon and bromine, gets broken, and this positive charge on bromine is neutralized by this lone pair, that is 2 electrons between carbon and bromine, and this bromide ions attach on this carbon. So results in the formation of CH2 single bond CH2, one bromine to this side and one bromine is on this side. So it is 1,2-dibromoethylene. 1,2-dibromoethylene. So simply it is addition type of reaction. Isn't it? So this is the mechanism of electromeric effect. It is the addition of bromine or chlorine across double bond, and is a characteristic test to check the unsaturation present in organic molecule. Now next one, that is, if you consider the unsaturated compounds, isn't it? Now if you consider this effect is temporary effect. Why this is temporary effect? Because if you consider CH2 double bond CH2, and suppose bromine molecule is there, isn't it? When this bromine approaches towards this pi bond, then and then only there is a positive and negative poles are created on substrate 1. When you remove this reagent away from that substrate, it molecule reverts again, comes back to its original state. That's why it depends upon the reaction condition. Okay, this depends upon the reaction condition. That's why it is temporary effect. And out of this electronic effect, all those electronic effect, this is the only electromeric effect is the temporary effect. All other effects are permanent effect. Isn't it? Now one more point. If you consider the benzene, yes, if you consider the benzene, and if you add the chlorine, isn't it, in presence of anhydrous is chlorobenzene with HCl. Now if you look this reaction one, this is also explained by means of electromeric effect. But as far as mechanism is concerned, the mechanism of explanation of halogenation of alkene or alkyne and halogenation of benzenes are different. In case of alkene or alkyne, it is addition type of reaction. But the halogenation of benzene is concerned, it is not addition, it is substitution reaction. Why it is substitution reaction? Because here H is there. So in this chlorine dash chlorine, this chlorine is replaced. This chlorine comes here, isn't it? Instead of hydrogen, and hydrogen goes away with this chlorine. So it is position of hydrogen is taken by chlorine. That's why it is substitution type of reaction. Now same can be explained with the help of mechanism. How it is explained now see. So first step involved in mechanism to explain this one. Now see here, if you consider the anhydrous AlCl3, so first you know something about anhydrous AlCl3. This anhydrous AlCl3 is the Lewis acid. That is the AlCl3. Maybe it is the it may be AlBr3, isn't it? It may be FeCl3. All these are the Lewis acids which are electron deficient. They are in search of electron rich centers. So when chlorine dash chlorine with lone pairs, like this, with lone pairs, plus AlCl3, what happens? What happens? The electron bonding pairs between these two chlorine atoms gives one chlorine along with bonding, means chloride as a chloride ions, and it is Lewis acid grabs one chloride ion. So when this chloride grabs by the AlCl3, it is AlCl4 minus plus, it is the Cl plus chloronium ion, that is the Cl plus is formed, and this is Cl plus is our electrophile. Remember, this is our Cl plus is the electrophile. So this is the first step. In first step, simply Lewis acid captures the chloride ions from Cl-Cl, and chloride ions in the sense along with bonding pair of electrons, that is Cl minus, and this chlorine becomes electron deficient. That's why it is Cl plus. Now in the second step, what happens? This benzene. Benzene is there, isn't it? This benzene plus Cl plus. Now this benzene in the sense electron rich. This benzene is the electron rich. So as it is electron rich, this electrophile attacks over pi bond. So as it attacks over pi bond, what happens now? See, yes. Suppose it attacks over pi bond. Then it approaches to the pi bond. Then this pi bond shifted on this side. So it will become negative charge. So as negative charge in the sense Cl minus attacks on this carbon atom, at the same time it becomes positive. So this can be explained or written in this way. That is the here negative charge, so it is positive charge. Here one bond pair, and here hydrogen and chlorine are attached, isn't it? This is the structure is formed. Now if you write the resonating structure, now see here, we started in what is the first or second concept of the GOC, that is the resonance. And resonance is possible in all the molecules where the A double bond B C have either positive charge, negative charge, lone pair, free radical, or multiple bonds. So it is very important in organic chemistry. So A double bond B C have positive charge. So resonance is possible. So as resonance is possible in the sense this pi bond shifted between positive and this carbon atom. So it becomes this is positive. The structure is like this. It is hydrogen, it is chlorine, here positive, like this structure is formed, isn't it? Now again if you check, A double bond B C have again positive charge. So here shifted like this, here positive charge, like this. So it becomes hydrogen, this is chlorine, and here positive charge, and here it is pi bond, isn't it? Now in this case, for the shifting, there is no pi bonds are further, isn't it? So but there is a hydrogen atom. So this hydrogen atom, pi bond, two electrons or bonding electrons between hydrogen and carbon, they are shifted in between. Yes, here one more bond shifted in between positively charged carbon and this carbon, and hydrogen is removed as a H plus. So structure becomes, there is like this. hydrogen becomes removed as H plus. So H plus remove minus, and it becomes here double bond, here double bond, here double bond. This is chlorine. So this is the final product, that is the chlorobenzene. Final product is the chlorobenzene, and one H plus is removed. And the third point, that is in first step, AlCl4 which is formed, AlCl4 negative which is formed, combines with H plus to form, that is AlCl3 plus HCl. And this is the AlCl3 the regenerating the added catalyst. सुरुवातीला ॲड केलेला कॅटलिस्ट आहे तो रिजनरेट झाला, AlCl3. It regenerates after this. HCl is the byproduct. Simply the mechanism of addition of halogens, maybe chlorine, bromine, isn't it, on the benzene substrate. But if you consider the mechanism of benzene substrate, it is simply substitution type of reaction, electrophilic substitution type of reaction, isn't it? And if you consider the double bonded, that is the unsaturated compounds like alkene or alkyne, it is simply addition type of reaction. Okay, so these are the points we covered under the electromeric effect. Okay, last point. So next point we see the reaction intermediates. Okay, good day.